Hello everybody, this is Cameron Snow, and in this video we're going to be continuing along with our series on geological risking for exploration. And this time we're going to be focused on how we do an assessment if we have multiple zones and common risk. So previously when we've looked at this, we've only been considering a single zone. What is the probability of success for a single zone? What's the probability of success for structure, seal, reservoir presence, and quality for one zone? But what happens if you have more zones? How do we handle that? What happens if the zones are completely independent versus if some of the risk are shared? So those are common risk. And that's what we're going to dive into in this video. So here are a couple of example scenarios. So here on the left, we've got the sand zone shown here in beige and yellow, and we can see that the upper zone is potentially a four-way structural trap that's immediately overlying its own source rock, and then our deeper zone here is juxtaposed against a fault, and it's got its own source rock here. Um, Whereas the scenario on the right, we've got one bounding fault, we've got two sand zones, one source rock, etc. So the question that we have presented to us here is, how do we perform the risking in this scenario? Um, Now, there are a couple of approaches that you can take, and I'm going to lay out three potential approaches. One, you can risk these entirely separately. So, for example, you can come in here and say, oh, well, you know, this is its own independent structure. These are, uh, they have their own independent source rocks and they'll have their own independent migration pathways. And, maybe these were different parts of the depositional system when they were deposited. And everything is completely independent here. So a failure in this zone means nothing for this zone. That's one possible scenario. Another possible scenario is they are almost one and the same. So here, for example, our structure is based on the same fault. Our source rock is, we only have one source rock here, and it's common to both of these. The migration pathway is maybe identical for these as well. The seal is all based on the same cross-fault juxtaposition. And maybe these sands were essentially deposited as part of the same system, not much time separating them. So we view their presence and quality. If one's present, probably the other is, and vice versa. So they are completely dependent. So you would just assess this as if it was one zone in terms of its chance of success, or maybe there's some combination. Maybe there are some components that are common to both and some that are independent. And that is the approach that we are going to take uh, in this example. So, you know, that's the decision we need to make: is are these risks common and shared among zones or not? Um, so what does it mean to have a shared risk? Having a shared risk means that if there is a failure for one zone for that risk, then there is a failure for all the other zones. Um, Now, it's important to remember that when we're looking at exploration, everything has to work in order for it to be a success. You can have, you know, good high quality reservoir present on a structure with excellent seal, and a clear migration pathway. But if there's no source rock, or that source rock isn't mature, then it doesn't matter. There is going to be a failure. So all it takes is for one hydrocarbon system component to fail in order for your well to be a failure. Now, with a common risk, and when you have multiple zones, what that means is if there is a failure in that common risk, all of your zones are going to fail. Now, this is this is something that you know maybe should be intuitive, but a lot of times I see it ignored. So like I was saying, we have three sands on a structure, but they're in a migration shadow. So if one fails, they all fail. That's the type of thinking that we have here. Now, that's a common risk. Now let's think about risk independence. Um, is the risk independent of the other zones? So let's think about this for each hydrocarbon system component. For our structure, is it dependent on the same structural trap, or is it a different trap or trapping mechanism? Do we have the same, is it the same fault that every level is dependent on? If so, that's common. If not, then we have we have at least some level of independence between the zones. Do we have the same cross fault seal, for example? Or the same top seal, or uh, something along those lines. If it's the same, then perhaps it is a common risk, and we need to say that if it fails for one zone, it's probably going to fail for all of them. This is especially common for things like shale smears. Uh, with respect to reservoir, you know, is uh, is reservoir quality and presence expected to be driven by the same mechanisms? So let's say we're thinking, we're in an area where reservoir quality is often driven by burial. So let's say we see in this area that it's burial driven compaction, and we see reservoir porosity degrade with increased burial depth. If all our reservoirs have been buried to 15,000 feet and then brought back up, um, you know, the reservoir quality is likely, degraded in all of them. So that needs to be viewed as a common risk or a shared risk across all of these. Um, so that's an example there. For source rock, are the zones expected to be charged by the same source rock, or are there multiple source rocks present? Um, if they're all depending on the same source rock, then source is a common risk. And this is probably source and migration are probably two of the most um, most regular common risk that we encounter, because often there will only be one source rock in an area that'll have charged all of the zones, and so it will be a common risk in your wells. And then migration, do the different zones in our prospect depend on a common migration pathway and timing? And if so, that would be a common risk. Um, so, how do we then account for this? Now, I've seen people go in and do some very complicated statistics, and I've been guilty of this myself in the past, where you go through and you say, okay, well, we look at the probability of failure for source and migration. We combine those together, and then we multiply that by the probability of success for reservoir, seal, and failure, and we do this at each level. Um, you can get to an okay mean answer there, but it's going to break down as soon as you move away from the P50 or the mean. The real way that we want to do this is through a Monte Carlo simulation. So what we want to do is we want to run a Monte Carlo simulation for each shared risk, a Monte Carlo simulation for each independent risk, and then we want to evaluate which trials are successful. So looking at this in a very simple case, what is our, the chance of success for our upper zone, for our independent risk? What's the chance of success for our lower zone for the independent risk? And then what is it for our common risk? And we'll run each of those trials, and we see that, for our common risk, we have a failure in trial 2 and a failure in trial 3, and so that flows down. And here we have a failure in one of our independent risks, so that flows down. And so that's the way this works, is we run the Monte Carlo simulation on both our common risk and our shared risk, and then we look at each of those trials to assign whether or not this was a success or a failure. Now, before I wrap this up, uh, you know, I want to make a pitch here for doing these Monte Carlo simulations using a system. So, you can go through and you can do this in Excel. The problem that you may have doing this in Excel is consistency. All it takes is, a small typo or an error, and you're going to accidentally bias your Monte Carlo simulation, and you're going to be doing this incorrectly. And a lot of times I've gone in and I've seen people do this in spreadsheets, and spreadsheets get copied and modified and copied and modified and copied and modified. And by the time you're, 5 or 6 or 10 copy and paste down the line, you start to introduce some errors. So that's why I advocate for doing this programmatically. And maybe instead of trying to roll your own solution, you should use a commercial solution like GeoRiskX. So, if you'd like to check that out and see how Monte Carlo simulations can be done and done consistently, check out georiskx.com. All right, hope this video was useful and gives you something to think about in your risking. In our next video, we're going to be talking about how we go about evaluating volumetrics. Thank you.